video I'm going to do OCR A-Level Maths, Paper 1, June 2023, Question 12. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition both online and in person. I live in Buckinghamshire, England. Please like and subscribe. Question 12. Use the substitution u equals e to the x minus 2 to prove that this formula, to show that this formula u equals e to the x minus 2, show that this formula, which is the integral of 7 e to the x minus 8 over e to the x minus 2 squared is dx is equal to another formula in terms of u, which I won't write down at the moment. So, okay, so what we need to do is we need to do a little bit of rearranging to change all the parameters in this equation to be terms of u. Well, we can already see that the bottom is going to be the same as u squared, so we need to work out what the top will be. So if we times this substitution by 7, we would have 7u is equal to 7 e to the x minus 14. We need 7 e to the x minus 8, so we need to add 6. So 7u plus minus 8 plus 6 is 7 e to the x minus 14 add 6. So 7u plus 6 is the same as 7 e to the x minus 8, which is the top. Last thing we need to do is work out about this dx. Well, we know u is e to the x minus 2, so if we differentiate that, we'll get du dx is e to the x. So this tells us that du over e to the x is dx. What about this e to the x though? Well, we know from above u plus 2 is equal to e to the x, so therefore du over u plus 2 is dx. So using that substitution for the integral, we'll have the integral of 7u plus 6 is the same as the top, over the bottom with the square, so u squared, times dx, which is the same as du times u plus 2. And if you look, that is actually the same as the required formula. They just write this as a single denominator here, and that will complete it. Okay, part B of the question is show that this integral, which is again written in terms of x, is equal to a plus natural log of b, and we're given the limits of natural log 4 and natural log 6. Remember, that's x equals natural log 4, x equals natural log 6. Is equal to this value. Okay, so 12b, we can already use our substitution to change everything to be in terms of u. So the original formula is the integral from ln 4 to ln 6, 7 e to the x minus 8 over e to the x minus 2 squared dx. So if we change that in terms of the formula we've already worked out, it's 7u plus 6 over u squared times u plus 2 du. We also need to change the limits though. So we can see that when x is equal to natural log of 4, we know from above that u is equal to the e to the x minus 2. So this would be, u will be e to the natural log of 4 minus 2. E and natural log are opposite, so it would just be 4 minus 2, which will be 2. So this gives us here. And when x is equal to natural log of 6, again u is equal to e to the x minus 2. So u will be e to the natural log of 6 minus 2. E and natural log are opposite, so 6 minus 2 is 4. And this gives us the limits of our integral. Now, when we're trying to do this integral, it's a little bit difficult because it's not one where we can just differentiate at the bottom to get the top. So we need to split it up using partial fractions. So what we want to do is find out how to split this fraction here. So we still end up with 7u plus 6 over u squared times u plus 2, but write it as 3 separate fractions where if we differentiate the bottom, we get the top, or maybe we can do it by inspection. We don't actually know what those fractions will be, but we can guess that the denominators will be a, where a is a constant, over u, plus b over u squared plus c over u plus 2. And the reason I'm using this triple equal sign or identity is because this has to work for all values of u. So if we expand this out, what we want to do is make these as a single fraction with that same denominator. So we'd times a by a u and u plus 2. So we'd have, let's write it like this, 0u squared plus 7u plus 6 is equal to a times u plus 2. And then b we would have to times by u plus 2. And c we would have to times by u squared. And the denominators would both be u squared times u plus 2 over 2 on both sides. So they're equal. So it's only the numerators of the fractions that have to be the same. So if we expand this out now, we've got 0u squared plus 7u plus 6. And here we're going to have a times u squared plus 2a times u plus b times u plus 2b plus c times u squared. And we can equate the coefficients here. So the u squared terms have to be the same, which is 0 is equal to a plus c. The u terms have to be the same. So 7 is equal to 2a plus b. And the constant term has to be the same. 6 is equal to 2b. So you can see from the bottom one that b has to be 3. So let's go up here. b is 3. If you work backwards, if b is 3, 2a plus b is 7. So 2a is 4, which means that a is 2. And then if a is 2, c has to be minus 2. Okay, so having split this into partial fractions now, I'll do it on the next page here. The integral now becomes the integral from 2 to 4 of, remember it was a over u, so 2 over u, plus b over u squared, so plus b over u squared, and then c over u plus 2, and c is minus 2 over u plus 2, and that's all du. Okay, now we can actually immediately do that integral, because this will be, let's do it here. So the reverse chain rule, if we differentiate u, we'd get 1 on the top. So that means it would be natural log of u would be, if it had been 1 over u, it would be natural log of u, but there's obviously it's 2 times that, so it would be 2 times natural log of u. Here this is b u to the minus 2, so if we, sorry, that should be a 3, b was 3, yeah? So it would be 3 times u to the minus 2, the integral of that will be minus 3u to the minus 1, or minus 3 over u. Yeah. Likewise here, if we differentiate the last one here, differentiate the bottom, we get 1 on the top, and that's 2 times 1 on the top. So it will be so the reverse chain rule applies again here. So this will be minus 2 natural log of u plus 2, and we need to put in 4 and 2 as the limits of the integral here. So we can now do this. If we put in 4, we're going to have 2 natural log 4 minus 3 divided by 4, yeah, and then minus 2, 4 plus 2 is 6, minus 2 natural log of 6, and then we're going to put in 2 as the other limit, so 2 times natural log of 2, right, minus 3 divided by 2, yeah, and then the last one will be minus 2 times 2 plus 2 is 4, natural log of 4. What we can do is now take out the brackets, also we can bring this 2 inside here, so it will be natural log of 4 squared, which is 16, minus 3/4, we can bite this one, bring the 2 inside, will be 6 squared is 36, so natural log of 36, bring the 2 inside here, so it'll be 2 squared is 4 minus natural log of 4. This is a minus minus here, so it'll be plus 3 over 2 here. And then here this was a minus minus again, that also turns into a plus. And then the 2 inside 4 squared is 16. Okay, so if we now look at the log terms, we've got a positive 16 and a positive 16, and we've got a minus 36 and a minus 4. So we can combine all the logs into one log. So it'll be 16 times 16 on the top, and then 36 times 4 on the bottom here. Right, and what we can now do is combine the non-log terms. This is 1.5 or 6 over 4 minus 3/4. So that will be minus 3/4. Yeah. And then what we can do is simplify this fraction here. So it's actually natural log of 256 over 144 minus 3/4. Both of those are on the 16 times table. It's 16 16s is 256, and 16 times 9 is 144. So it's natural log of 16 over 9 minus 3/4. And that completes question 12.